We're supposed to find out which of these parametric relationships matches this graph over here. So you can do it the old-fashioned way, making a table and then seeing what x and y values result. So something that might be useful since it's trig is let's try plugging in 0, because those can be quick values that we can get. Remember, cosine of 0 equals 1, because cosine represents the x coordinates on the unit circle. So 0 degrees is 1 comma 0, because the unit circle has a radius of 1. So cosine of 0 is 1, and then sine of 0 is 0. So with that in mind, let's check out the first equation, see if we can eliminate that. If you plug in 0 in for t, this is cosine of 0, so that makes 1. So x is 3. We have an x coordinate of 3. And then if you plug in 0 in for t here, tangent is just sine over cosine. So since this is 0, we have 0 over 1. So that makes this be 0, and then 0 minus 1 makes negative 1. So we should see a dot at 3 comma negative 1 if this graph is correct. So since it's not there, we can eliminate this option. Okay. If you didn't want to do this, the other way would be trying to maybe use the Pythagorean identity, try to get x and y to be in Cartesian form. I think with some of these it's going to be too tricky though, because of tangent and cosine. There's probably a method to do it, but it's just going to be way quicker to just think about certain values. So I'm going to just draw a little dividing line, because this goes with this relationship up here. Let's do the same thing for the next relationship. Let's plug in 0 and see what comes out. 3 times 0 makes 0. 0 minus 1 makes negative 1 for x. And then over here, cosine 2 times 0 is 0, so cosine of 0 is 1. 1 times 3 is 3. So we should see a dot, negative 1 on the x, 3 on the y. So this one's eliminated. Let's go to the next one. If you plug in 0, that's sine over cosine, so that's 0 over 1, so it's 0. 0 minus 1 makes negative 1 for x. Plug 0 in here, that gives us 0 for y. Negative 1 on the x, 0 for y. This one's a possibility. We can't eliminate option 3 here. Let's check out option 4 and option 5, because if we can eliminate those based on this t equals 0 point, then we can just stop there. So plug in 0, and then we got sine over cosine. So this is 0, and then if we plug in 0 here, this is 3 minus 1 makes 2, so 0 on the x. Oh, this one's an option, so we can't eliminate the fourth one down. And fifth one down, we're going to plug in 0 for t. This is 3 times 1 minus 1 makes, so we get 2 for x, and then 0 for y. If we go 2 in the x, 0 in the y, so all three of these are still options. This one goes with this one, this one goes with this one. So you need to try to find another point that you could plug in. Other easy points to plug in. Try plugging in pi, or maybe pi over 2. Let's try plugging in t equals pi over 2. Remember, cosine of pi over 2, that's 0, because on the unit circle that's 90 degrees. The x-coordinate is 0. So if we plug in pi over 2 here, this is sine over cosine. So sine pi over 2 is 1. Cosine pi over 2 is 0, so that's undefined. So pi over 2 isn't going to work for this one because it doesn't give us defined values. Let's try going with pi. Let's plug in t equals pi. This is 3 times sine pi over cosine pi. Cosine pi is negative 1, sine pi is 0, so this is 0. 0 minus 1 gives us negative 1 for x. And then if we plug in pi here, and that gives us 3 sine 2 pi, so that gives us 0. So negative 1 in the x, 0, so we got the same point. And this one is still possible. Yeah, it's the same coordinates as what we had before. Maybe plugging in pi over 2 will help us eliminate some of the other ones. If we plug in pi over 2 here, that's still going to be undefined, because tangent, that'd be something divided by 0. So let's plug in pi here. This is 3 tangent 2 pi, so that's going to be 3 times 0. X equals 0 in this case. If you plug in t equals pi, my writing's getting messy, but if you plug in t equals pi, you get x is 0, and you get y is, that's negative 4. So at 0 on the x, negative 4 on the y, that doesn't cross, so it looks like we can eliminate this option. And then let's try plugging in pi over 2 down here. That will work because we don't have tangent, we're not dividing, we don't have a divide by 0 problem. Cosine pi over 2 is 0, so x equals negative 1. Sine, now this is 2 times pi over 2, so this is sine pi, so that's 0. So that's a coordinate, negative 1 comma 0. That is a dot on our graph. We can't eliminate this option. Let's put it even more to the test. Let's plug in t equals pi. Then this is x equals negative 4, y equals 0. Negative 4 comma 0, that's a dot on this graph too. So it's a contest between these two. I can't seem to eliminate either one of them. If we try to do something like pi over 3, we're going to be involving square roots, and that's harder to see on a graph. Just thinking what else we have for options. You could try 3 pi over 2. It's going to give us 0 in the denominator here, though. I don't know if we have much of a choice. This one, let's try plugging in t equals pi over 2. That's a known trig value. Sorry, we already did pi over 2. Pi over 4. Because we know sine of pi over 4 is square root of 2 over 2. We know cosine pi over 4 is square root of 2 over 2. So tangent pi over 4 is just going to be 1. So that's 3 times 1 makes 3. 3 minus 1 makes 2. And then if we do that over here, this is sine 2 times pi over 4. So that's sine of pi over 2. So that is 1. 2 on the x. 3 on the y. Oh man, that's close. I think we can eliminate this one though, because that should land right here. So we can eliminate that option. This is the last option.